Hello, my dear friends. Welcome to this new video in which we will learn how to build a robot car that can avoid obstacles using Arduino, L293D motor shield, a servo motor, and an ultrasonic sensor. This car will constantly scan its surroundings, and if an obstacle is detected, the car will change direction to avoid it. First, I designed these mounts using 3D design software Autodesk Inventor. These mounts will help me to secure the Arduino board, the servo motor, and the ultrasonic sensor. After I finished designing these parts, I printed them with a 3D printer. Now I will start assembling the robot, and the first step is to assemble the battery holders. I will mount these holders onto the robot chassis using appropriate screws and nuts. Then I will solder the cables of the holders in series, so that the 8 batteries are connected in a series configuration, resulting in a total of 12 volts as the maximum voltage. The second step is to install the switch. I will add this switch in its place on the robot chassis, then I will solder one end of the switch to the positive terminal of the battery series. After that, in the third step, I will prepare the DC motors. I soldered the wires to the terminals of the DC motors, then I installed the DC motors on the left and right sides of the chassis using appropriate screws and nuts. Then, in the fourth step, I prepared the Arduino holder. I heated the threaded inserts using a soldering iron and pressed them into the corresponding holes in the 3D printed holder, as you can see. Then, in the fifth step, I attached the Arduino holder by fastening it to the chassis using appropriate screws. Then I placed the Arduino microcontroller on the holder and secured it using screws. After that, I inserted the Arduino motor shield into the Arduino microcontroller. Then I ensured that all pins were aligned correctly, and then I prepared the wires that I would connect to the Arduino motor shield. Then in the sixth step, I will secure the servo motor holder using double-sided tape. I inserted the SG90 servo motor into the holder and secured it firmly. After that, in the seventh step, I installed the ultrasonic sensor by inserting the ultrasonic sensor into the printed holder, then securing the holder onto the servo motor. I also connected the wires of both the servo motor and the ultrasonic sensor to the Arduino. Then in the eighth step, I installed the support wheel, securing this support wheel to the chassis using appropriate screws. Then in the ninth step, I attached the wheels to the motors on the left and right sides. In the 10th step, I connected the components electrically, as you can see in this diagram. I connected the wires to the Arduino motor shield. After I finished the electrical connections, I added the batteries in their place. After completing the assembly of the robot, I will now program the Arduino board, and the program is as follows. I will need the servo library and define the object Servo and the variable POS to handle the servo motor. Then I will define the Arduino pins that will interface with the motor driver to control the DC motors. Then I will define the pins that will interface with the ultrasonic sensor. Then these two variables to record or save the distance and the duration, and these two variables to save the current angle of the servo motor and the direction of rotation. Then in the setup function, we will set pin 5 of the Arduino to control the servo motor, then we will define all pins to be outputs, output, then we will activate the brakes to prevent the motors from moving. After that, we will set an initial value for the servo motor. Then in the loop function, we will read the distance and save it in this variable, distance, using this function, measure distance. The measure distance function, which I wrote here below, handles the ultrasonic sensor by sending a wave and receiving it, and thereby calculating the distance. Then in this line, the distance is checked. If it is less than 40 centimeters, the speed is adjusted to match the distance. For example, a distance of 20 centimeters will correspond to a speed of 75, and a distance of 40 centimeters will correspond to a speed of 128. Then the motors will be rotated using this function, motor turn. The motor turn function, which I defined here as well, takes the pin for direction and the pin for speed as inputs, then the direction, then the speed, and gives commands to these pins to move the motors according to the desired speed and direction. Then the distance is checked. If it is less than 15 centimeters, the motors are stopped, and the distance to the left and the distance to the right are checked using this function, check direction. The check direction function takes the angle as input, then rotates the servo motor to this angle, then measures the distance using the measure distance function, and returns the measured distance, which is saved in this variable, left distance or right distance. Then both distances are checked. If they are both less than 15 centimeters, the robot will move backward by reversing the motors, and thus it moves backward for half a second, then all motors are stopped, then the distance is measured again, or the distance to the right and left is checked. If the distance to the left is greater than the distance to the right, the robot turns to the left, and vice versa. If the distance to the left is less than the distance to the right, the robot turns to the right to move to the empty space. Then the brakes are activated, then the servo motor is reset to start in the middle. If this condition is not met, meaning the distance is greater than 40 centimeters, the motors will move forward at a speed of 100, and the servo motor and sensor will scan by rotating left and right. When it reaches the far right, it returns to the far left, within a range between 30 degrees and 150 degrees. So, I have finished explaining this program. I will now upload it to the robot and we will conduct a test. We reached the end of today's video. I hope you enjoyed and benefited from it. Don't forget to like the video and subscribe to the channel to stay updated with all new content. Share your ideas and inquiries with us in the comments. Until next time, stay creative and exploring.